It's been 1 month since I've thrown my glove in the court of mainstream physicists, and no one has picked it up yet. I know that quite a few of them are aware of its existence, and I even got some kind of a reply to my challenge, but thus far no one wants to cross swords. Perhaps I'm not noble enough, I've thought for a while. Or could it be that those I am challenging do not really understand where I come from and what I am heading for? After all, I have been told that no one in a group at Cambridge could see anything strange in my video, which really annoyed me. I must tell you that for a while I contemplated all sorts of answers to that, until I remembered some sage advice from Leon Lederman. A PhD is even less a measure of credibility than a Nobel Prize, or something like that. Sorry, Leon, if I misquoted you. That compelled me to hold my horses and calmly present my 3 cases once again, this time with the explanations I had considered unnecessary in my first video. Let's thus start with case number 1. The basic Newtonian experiment in optics is well known and, according to the conventional physics, well understood. A beam of light passed through a triangular prism is refracted and dispersed, which results in a display of what Newton called the spectrum of light. This spectrum has a distinct distribution and orientation, with red light emerging from the narrow part of the prism towards the vertex, orange a bit further down, yellow a bit further down still, and so on until the last color of the spectrum, violet, exits from the thickest part of the prism in comparison with the other colors. The reason for this distribution and orientation of the spectral colors I will not discuss, for even high school students know what the conventional theory says about that. Let me just call this the Newtonian orientation of the spectral colors. Now, the conventional physicists may be satisfied and believe that that is all that could be concluded from the basic Newtonian experiment, but I challenge that. And I have good reason to do so, for if one uses the same setup but looks through the prism instead of projecting the emerging light onto a screen, one can also see a spectrum, but with a radically different orientation. Just have a look at the following image, or even better, try it at home. This image of the spectrum is nothing else but an inverted image of the spectrum displayed on a screen. Violet towards the vertex instead of red, blue a bit further down instead of orange, and so on. Or is the image projected on a screen an inverted copy of the image one sees when looking through a prism? Now, Newton never talked about this. Goethe never did either, and contemporary textbooks on optics are silent or ignorant on this subject, as far as I know. Only Aristotle apparently talked about it, but I will not elaborate on that, for his final conclusions were wrong. Hence my calling this distribution, or rather orientation, the Aristotelian one. This observational fact raises a host of questions which demand definite answers. Firstly, where is this image, the Aristotelian one, coming from? Secondly, is there a connection between the 2 different images or orientations? Thirdly, if photons travel from their point of emission to wherever they are intercepted without losing their identities, meaning energy, wavelength, frequency, how is it possible to see the Aristotelian image but not the Newtonian one? Think about this. I don't have time to explain. Now let me conclude this first case by asking the conventional physicist, can you answer these questions? I can. In fact, I have already given you half the answer in my first video. Let's look now at case number 2. I must tell you that in regards to this case, I did get some kind of an answer, which was that what is seen in this case are simply colored fringes, which was apparently explicable because I did not use a focused point of light. I replied by saying that it makes no difference and I'm willing to debate this, especially when one considers what is seen when interfering with the beam of light diagonally and then vertically. Again, think about it. I cannot elaborate more in the 10 minutes I have available. Finally, in case number 3, I am interfering with the light after it has passed through the prism. The photons of different colors have already been refracted at their respective angles, according to the conventional understanding, and yet I seem to either move them around or create new ones. Can the conventional physicist explain how this is possible? That's all for the time being. I believe things are clearer now, and therefore our duel may begin in earnest. One final word. If by keeping silent you believe that I will eventually go away, you are wrong. I'll haunt you until you'll take a stand, which is the only honorable thing to do. Sooner or later you will have to come up with some answers, and then the world will learn that little bit more about the nature of being. It is such a pity, though, that you refuse to see what a beautiful explanation there is for all the conundrums I have presented, an explanation which, incidentally, will render the current gibberish depiction of the quantum world into a flawlessly intelligible one. Mark these words.